Hello, good day. My name is Topman Paul-Dike, and I welcome you to section 2 of the series I titled Simple Shell in C, where we're learning how to write a simple shell, you know, using the using C programming language. Okay, this is the part we've been taking. This is um, our journey on paper. So I hope that we're going to get to the very end and implement these things. My intention is not to get your project done for you, something, but is to make you confident enough, even if you are a newbie, wandering in the valley of the shadow of confusion. Even after following this series from the beginning to the end, there is this confidence, level of confidence that will come. You just be glad you did. So I say that to say that we may not learn everything here. We just might not be able to cover everything, you know, but we'll cover things that are considered enough, basic enough. So make up your mind to read documentations, go for other resources that you can go to. That you can go for that will give you advanced knowledge, of the subject matter. Okay, so if you missed the previous section, please do well to go and watch it. You find it on my YouTube channel on this playlist, Simple Shell in C. Okay, all right. I don't want to start making unnecessary repetitions. So do well to see the previous section. In today's section, we'll be covering these objectives that I've listed here. Okay, first is the need for getline, how to use it. I appreciate your feedback. I got some feedbacks, from you. So it's really important. Okay, let me know how impactful it is. You know, a short comment will do. You know, thumbs up, like, help me build a YouTube algorithm. Okay, it's it's important, right? So one of the feedback I got, I think I want to share with you, is someone informing me, um, calling my attention to the fact that AV is not terminated. What do I mean by that? Let me show you. So I wrote this file in the first section. I did not add this when I was doing it. So he called my attention to that null is always the end, the last thing, you know, the last thing you find on this array of strings, or command line arguments. Okay, as by the way, so this is section 2. Let's do some work. You know how I do it, right? I will create a new tab. So I have two tabs now, one here, one here. Let me make this one visible enough. Okay, I like it so that I can use one as editor. I can be doing more than one thing at the same time on the same um, computer system. That's why I do it. Okay, I'm going to make this full screen. Now let's begin with trying to do something that looks like a shell, something that gets input from the user, that can be able to take command that prints a prompt. Now we know that it is a shell that is printing this prompt. It is a shell that is running. Of course, it's bash that is printing this prompt here, and that's the reason. And this blinking cursor here is waiting for input from the user. So that's we're trying to build something like this to that print a prompt and wait for input from the user, and does something based on the input received from the user, right? So let's try to write something. I'm going to copy the file from the previous section just to, I think it will be faster that way. I will then take off the things I don't need. I'm going to name it shell.c here. Okay, so we now have it here. I'm going to open it with nano. If you've been following from the previous section, I don't need to explain what nano is. Okay, so let me take off these things for now. Comment this one off. Don't need now. Comment this one off. I will clear this one, and I'll also take off everything that is here. Okay, so maybe bring up my return value. Return 0 and this function. So what do we want to do? We want to print a prompt to the user. So let me take all of this off and have a prompt that looks like this, a dollar space like this. Okay, how do we now get the input from the user? I'm sure most of us, if not all of us, knows about scanf and its capacity to get input from the user. So we just need to specify the format of data we are expecting from the user, and of course it's necessary as well for us to have it saved inside a variable here. Yeah, right. So we need to specify the size of the variable to avoid um, some memory error, right? So let's say 10 now. Yeah, is the size of this variable, size in bytes in memory. So now I'll specify that it should go to input and save whatever it gets from the user, and I want it to, for now, I want our share to just print it to the user. Let's just say your input %s and a new line. %s should get its its value from the content of input. Okay, let's see whether this is working. I'll save it. I'll go to the other terminal and I'll compile it. Please, this time I'm using make. Make is available in your Linux command, right? You can do your normal GCC stuff, but don't be confused. I'm actually compiling as well. So make is actually faster for me. So it has compiled. I have the executable file, green colored here. Let's run it. Yay, that's our share prompt there. So let me say echo. It says your input is echo. Let's play with code a bit. Let's play with code. Because the shell in real life does not end. It continues until you end it. Yeah, until you end it, it will continue, right? Until you give it what it's called EOF, or anything that sends the EOF signal, the end of file signal. So it could be control D, as it is on my computer here. It could be you typing exit. Otherwise, this loop will run forever. It will run forever. So let's make our own run like that. Let's play with codes a bit. So I'm going to do a while loop here. I'm going to have a while loop run here. Come on. Okay. Well, like this, I will say while. If it's a Python, would have said while true. But this is C, and true evaluates, true is represented by 1. So I just say while 1. Then I will indent all of this. I like to play with codes. So much fun. Okay. Let's see if this works. I'm going to save it. I will come here and compile again. Okay, compile with that error. So that's it. So ls, say your input is ls, echo, says your input is echo. What now? Less. Come on, it's making sense, right? PWD. So our program is already working. Printing our prompt steadily after look at the cursor is blinking, waiting for user input. Is that not interesting? So let me undo this stuff. What's undo again? Meta u. Let me take out the while loop so we could know what we are doing. That was interesting, right? So I will save this and then go back and stop this, recompile. Now let me show us the shortcomings of scanf, which most of us, if not all of us, knows already. So if I do ls-l, it says your input is ls. Is that not a lie? It took only ls. You know why? Scanf stops when it meets space. It stops there. It stops scanning. it stops scanning. Now even at that, for the fact that I have specified here that the size is 10, this is another trouble, because if I have something, okay, now in real life you may not have a command like this. Let's say there was a command possible like this: echo less cd pwd. It is more than 10 characters. Now see what happens. So there's an error. There's an error. It is not. It does not adjust. So I just might be forced to come and put to come and have if I have 100 commands on the command line, can be more than 100. Besides, considering the fact that scanf stops where you see space, what command in this life can be longer than 100? Single command with no space in between. So scanf is out of the game. Scanf is out of the game. So if I say 1000 and somebody else entered only ls, while I'm giving this guy a space of 1000, that is a waste of memory. You know. Of course, you can have commands that are long, yeah, quite lengthy commands. For example, if I say echo hello class, or that's what echo does, right? Echo prints it to the terminal. But if I do the same thing and redirect it into a file, it does not print to the terminal again. It now save it inside one file, right? So it is now the content of this file. I can echo something really long. Let's say echo, and I put a single quote here. I say hi PS. I am very happy to lead this spectacular section on simple shell implementation in C. I need to type plenty, let's keep it that, plenty and faster. So allow me to type some rubbish. So I go, here we go. I just want to have plenty. So when I'm done with what I'm typing, the moment I add this closing single quote, I'm saying I'm okay. But I don't want it to echo it to the output. I want it to be saved inside that file. So I go file. So it not echo anything. Let me clear. The file is still there. If I cut into it, you see that it has what. So I just type. So you can have plenty of things imputed. Plenty of things imputed. So how do we now have this thing adjust automatically? How do we have it minimize, become small when the input is small, become wide when the take a wide range when the input is wide? That's one thing that getline does for us. It reads the line for us. Let's check the main objective. Where are we now? Command line arguments, executing. Okay, command line arguments. Okay, this is actually read line. This is read line. Reading line. Okay, it's fine. Making progress. Okay, so we are saying scanf cannot serve us here at all. Scanf cannot serve us. We need to use getline. Let me clear this and let's go and take scanf out of this place. Scanf, you are not serious. Live here. This is bigger than you. So we'd rather use getline, right? Getline. But let's go and find out how do we use getline. How is it used? Let's read the Linux manual. Please, if invite others to join. Okay, if you're live, you can ask questions on something you don't understand. You can make contribution using the comments section, the live chat, or the comment section. It will be seen. By the way, please like the video. You admire what you're seeing, like the video. Don't just like it in your mind, like it in real life. Share with others, and do subscribe to this channel if you're yet to, please. Um, Now we've seen that getline. Uh, to use the getline function, you need this header file, right? We have it there already, and it takes 1 2 3 arguments. And so getline reads an entire line from the string, the entire line, right? And then it stores it in the address of the buffer containing the tests into line pointer. Now watch this. This is asterisk line pointer. This is asterisk asterisk line pointer. They're not the same, right? This guy now, it takes the address of this guy, and then because it has this address, it is able to store it inside the this you appreciate it more if you have if you know have knowledge of pointers. I have a playlist here. Okay, this playlist is the path to C. I'm teaching some C concepts here. You can see I taught pointers in two um, sections, and it's quite insightful. You might want to take a look at it. So if you understand pointers, this guy takes the argument that is the address of this particular pointer, right? And he goes there and changes the value by adding what is contained, what he got from the stream, into, by saving it inside there, right? Now this other guy is supposed to determine the size that will be allocated to this buffer here. What is a buffer? A container, a temporary storage, kind of, you know. All right, so okay, I think we're not interested in the return value now, are we? No, I don't think we are. So it goes there and save it. So when we're not trying to access this thing, we discover that it now has a new content, and that content will be whatever was streamed from here. Enough of the talking, let's go. Before we go, malloc as well. I think I've taken malloc severally. If you want to take a fresh one, you find it on the Code Tribe YouTube channel. Have I? No, I don't think. So, but malloc is used to allocate memory dynamically to a variable. Now, if you don't know what that means, don't worry. You can do without that knowledge for now in this section. Okay, so let's go. Now we have, let's take this to be the buffer, input to be the buffer, and I don't want to determine the size. I want to state that it has null value. This guy should do the allocation for me, because getline can handle it, right? It can handle the memory allocation. So the first argument I want to pass here. By the way, we need a variable of type size t here. Why? Because this guy's second argument is of type size t. Alright, so we need to declare such a variable here. And so size t. I could have called it n, but I choose to call it size. I could have also given it an initial value of 0, but I intentionally don't want to give it. If you know why I should give it an initial value, let me know. Because at the end of the day, getline can handle it. Getline can control it. You know. Well, that's by the way. So now let's pass the arguments. First argument will be the address of input and pass an input. Why am I using address of? Recall that this guy is a pointer already, right? This guy is as good as this input. Meanwhile, this other one needs something like this, a pointer. Let's say pointer, that we save the value of the address of input. You understand? So if I declare a variable of type char here, like this, if I declare a variable like this and pass this pt arrow as the first argument here, it will work. It will make sense. So we don't need to. I mean, that's an extra line of code. So why not pass it straight? That's why I'm passing it like this. And then we need to pass the address as well of the size, because this guy has to be a pointer. You know what? The first argument is a double pointer, second argument is a pointer. Right? That's you can see it here. It's clear. Double pointer, pointer. So it's either you give it a double pointer here, or you give it the address of a pointer. Yeah, it's either you give it a pointer here, or you give it the address of a normal variable. Now this one is a string. In our case here, of course, the string can be a file. The string can be, but in our case here, we are streaming from the standard input because we are getting the input from the user. Okay, so here will be stdin. Are we good to go? If there's no input, if there's no bug in this code, it should work well. But it's important that I free, knowing that get is allocating memory to input. It's important that I free it to avoid memory leakage. Yeah. Let's save. Let's exit this manual and let's compile that program once more. What is the matter? What is the matter? What is the matter? And input. Oh. Let's do it this way. Let me treat this guy like a pointer and see if that solves the problem. Okay, clear this screen for me. So what is the matter? What am I not doing right? Implicit declaration of free. Okay, free belongs to a particular. Do I need to free this guy? Wait, getline can handle it. So this guy wants me to add to include this library to be able to use free. But I'm thinking if getline is able to allocate memory to that stuff without me without having this library included, then I think getline will free it as well. Yes, maybe if we read fully the manual further, we'll find it. So I don't think I need to do this. Please correct me if you think otherwise. Okay, so let's clear the screen again. Alright, so just compiled now. Let's run our shell. ls is working, so my input is lx. Now notice that it printed an extra line. This is because getline adds an extra line, adds a line, new line already. So if I add this new line, if I don't remove this new line, it will be double lines. So let's save this and compile again and run it again. So ls is working well right now. Let's do it again now. If I do ls-l, it says your input is ls-l. Scanf could not do this. Scanf could not. Now let's even try to find out what the size of this. I didn't give this guy a size. Let's find out what the capacity, the amount of memory that getline allocated to it dynamically. So I will cut this, paste it here, paste another one here, and I will call this one, I say size equals this, and that will be it's of type size t, so it will be percentage lu, and the variable is size, and I want it to print a new line here just to separate this. I just want this so that it not be compacted. So let's see, let's go back, let's compile again and let's run it again. ls-l. So it this time I need to add a new line character. Okay, let's compile again, clear again. Hope you're following. Please let me get, is it flowing, is it making sense? Please type in the comment, let me see. If you're from, okay, let me not mention, if you're from LX identify, let me know. Alright, so it has given it a size of what? 120. 120. That means it's giving the range. Let me show you. As long as I make input within that range, the size will be at 120. If I exceed that range with my input, let me try to put something that threatens the range. It will, I think it will double it. So let's see. Oh, I've not even exceeded the range. Come on, let's go. So you see that 240, something that did not give any size, Meanwhile, I think it's a good practice to come and initialize this to 0. As a way of explaining your code. Okay, that is by the way we are making progress, right? Making progress. Now let us let us move to the next thing. Strtok, string tokenize. What does it do? What it does and how it works. What does it do? How does it work? I will find out. We'll find out. I think this file is saved, right? Let me exit and create a new file. I will call it. No, I want to demonstrate strtok separately first. Then I'll come and add it to that place. As I'm adding it, it is resembling a shell. As I make progress. So strtok. Here we go. How does strtok work? Let's clear the screen and look at the manual. Strtok, what does it do? String tokenize. All right. This is of course, this is not the one we're interested in. This is the one we're interested in. It takes 2 arguments, a pointer, as a string, and another pointer again, the delimiter, and So let's read. So this the strtok function breaks. Okay. First of all, take note. This is what you need to include this. Let me go and put it here at once. Yeah, and since we need to print some things out, I'll also include stdio.h. Alright, so int main void some kind of boilerplate, man. Alright, you're ready to code. Let's go back to the manual. So the strtok function breaks a string into a sequence of 0 or more non-empty tokens. What this means is it sees a whole string, and break the string into bits, into different pieces, right? So it says on the first call, come on, allow me to highlight this. On the first call to strtok, the string to be passed, mark this word passed, take note of it, should be specified in str. You can find out what passed means, or you can put a comment. What do you think passed means? Put a comment. That if that comment you're going to put, someone can learn from it. Put a comment. I can't be talking everything here, but pass is okay. Topman, continue what you're doing. So specified in the string. So the string to be passed is specified in the str. What str? This argument here is specified the string to be passed. In each subsequent call, actually, that should pass the same string, str must be null. Let's demonstrate what that means. But before we do that, let's find out what this other argument is. The delim, this stands for delimiter, right? Delimiter, that means the one that limits, that brings the limitation, that causes a limit. So the delim argument specifies a set of bytes that delimit the tokens in the pass string. What that means is the particular set of bytes that if strtok find it, it stops and breaks the strings there. Well, enough of the talking. Let's demonstrate that. So I'm going to declare a string here, Please, at this point, don't do it like this. You will, I don't know whether I explained this in my pointers video, pointers tutorial. You will cause issue. Don't do, let's say, um, string, okay, let's say sentence. You're looking for trouble, right? So rather take it off and have some square brackets here. You might have it empty for ease. You can specify this the size if you have that time. I O am O A O man O indeed. What am I trying to do? Watch out for it. Okay. Oh, undo. All right. So I want to call the function string tokenize. I want to pass the first argument as the string that is working on, which is what we have there, and the second will be the delimiter, and I want to say delimiter is space. I just put space in between two quotation marks, right? But then how do I see this work? I need to have it saved inside the variable. So let me declare a variable and save it here at once. So let me call this one car. Let's say car string equals to this. And when we do this, remember when we do this, we're trying to catch the return value. What does it return? It returns a pointer to the next string. What do I mean? Look at our return value. It returns a pointer to the next token, or null if there are no more tokens. Remember that each of these, when you're dealing with anything that has to do with strings, occurring like an array, you will have null as the last thing by default. You don't need to put it; it will be there by default when it gets to the end of the string. All right. I hope that was communicated. Now, string token. Don't worry about the bloody grammar. You explain. I said you explain. I'm trying to explain it right. You will see what string token will do now. Let me now ask it to print. Print what we have in string. So percentage %s. Let me ask it to print a new line. A new line. So okay, string. Are we good to go? Let's go and find out what happens right now. Let's go and find out what happens. So if there are no bugs in this code, it should run well. I'm going to exit this manual. Here's a file. I'm going to compile it using the make command. I chose to use make command today. So that is, it compiled that error. Let's run it. Excuse me. What is happening? Let's check. There's a bug in my code. It's not functioning as expected. And what could that be? Oh. Could this be the problem? No. What could be the problem? If you've seen the problem, let me know, please. If you're watching and you've seen the problem, let me know. Okay, so now I won't compile. When I put you over beforehand. MU undo. So what is the matter? What is the matter? Sentence. Okay, let's do this. Let me declare a variable out here. Let me call it delimiter, and let me see if that is equal to space. Oh, okay, it's working well. Everything is working well. I'm the one not. Oh. I'm the one making the mistake. There's no space in that string. So what I'm actually saying is, only anywhere you see space, break the string. And so it's obeying my instruction. So it's doing what I ask it to do. Actually meant to say, anywhere you see O, break the string. Right, so let's clear the string, clear the screen. Sometimes these mistakes help us learn better. Alright, so you can see it printed only I. Only I. That's because after I it saw O and it stopped there. Now let's see that thing. When you're calling it the second time, that thing we read from the manual. When you're calling it the second time and you want to continue from where it stopped on the first string, don't put anything here again. Just put null. Don't put any other string here. Your first argument should be null. What do I mean by that? I'm going to copy, I'm going to call it yank this and have a copy and have it pasted here. But this time we're not declaring a variable again, just say string equals this. I think I should do something here. Let me separate a variable declaration, and say string equals this. I've not done anything strange, have I? So this time, since we're calling it the second time and want it to go and continue, what we'll do is we'll pass null here, and I want to have this. I want to have this as well here. Okay, so I'm printing from the same variable, right? Let's find out how this works. Okay, back to this terminal, compile again, no problem. Look at that, it printed I am. Have you noticed that I just used O to separate I am a man indeed? Maybe you've not found that. Let me now copy this and have them pasted some more. And so I'm going to have copy the same thing from here. If this was emails, I would have done that easily, faster. But let me just do this. I need how many more? 1, 2, 3, 4, 5. So 1, 2, 3, 4, one more, 5. And let me get getppid as well. Copy this on me, yank it here. Alright, give me space, yank here, give me space, yank here. Okay, let's save this. Let's go and run it again. So compile, no error, run it. I am a man indeed. I am a man indeed. That delimiter can have more than one thing. I can still go and add space in that delimiter. Let's find out. I can go and add inside this delimiter. That's why it's a string. You can see it's only one thing that I put there, but it's a string. If I go and add, let me now save it here. Let me declare it separately here. Car. I can call it delim. I just like being unconventional while teaching, like with all this naming. Let me call it stop at. Right, stop at. Let it be equal to O. But this time I want to add space. Space. See the importance of variable. Otherwise, I'll be adding space in all of them like this. So I just pass stop at. So if I had this variable before, I would have been solving myself like this. Stop at. stop at stop at. I am missing Emacs right now. Stop at. I'd have been faster with this thing I just did now. Alright. So I haven't said that you should stop where you see space. Let me now put space here and see whether it will be. Space here. And let me put space here as well. And save this. Are you following? Is it flowing? Talk to me. Let me see some comments. Compile. What? Why? What is that? What is happening? Expected. Oh, just something I did not add semicolon. Okay, I did not add semicolon after declaring this. Alright, so save. Go back. Let's compile again. That's compiled. I'm going to clear the screen, and then I'm going to run it. I am a man indeed. You can see that it is treating both space and the letter O as the delimiters. What it is doing is this. Let me show you what it is doing. What it's doing is it will come here. It will look at I. It will create an array of characters. Then when it meets that delimiter, when it meets your delimiter, I, it says I. Once it meets O, it will turn the O to the null byte. Right? Let's see. So this is the first character I, comma. This one becomes null byte. You know. I hope I spelled null byte well. Okay. Excuse me, please. Okay. That's it. And then it comes here and continue reading from here. So it will have the character am A and take the character M and then add the null byte. Am I writing this thing well like this? That's written null byte. So which of course can be simply presented like this: A and null byte. It will turn that delimiter to the null byte. You know. Am I writing this null byte correctly right now? Whatever. Okay, so that's what is happening, right? That's what's happening. So it should now break it into a certain number of strings depending on how many times it meets your delimiter before it meets the null character. But now, how do we now tell when it is the end? I mean, this time we had coded the string, but when we get it from the user, how do we now effectively look through it and do all of this without and check to see when we have gotten to the end, to the when it produces null? Now I counted it myself. I was one that typed it, so I counted it myself. But we want to write a simple shell, and we can't tell how lengthy or the number of strings that will be imputed by the user. Now the essence of tokenizing the string is so that in case this thing was a command like, let's say let's say echo now let's say echo can take an argument like -e, and then let's say simple shell. If you're familiar with Markdown syntax, you can tell what this does. Alright, so when someone enters an argument like this, you know, on the command line, we want to be able to tell which one is the main command and which one is the argument. And getline that we are dealing with, getline will just bring everything like this. It will not separate them. It is this string token that will now break it into bits. And in this case now, when we put in oh here, I'll just say space. When you see space, you break. Stop there. So when it breaks it now, we are not able to take whatever was the first one as the argument. And in our simple shell, we'll not check to see whether that is the valid command. If it's a valid command, we'll go ahead and run it and call it from the bin, from the binary directory. If it's an invalid command, we'll print an error. Right? So how do we now write a logic that will make us not be doing all of this again and again, again and again? That will make us that we work for no matter the length of this thing. So that's what I'm going to do right now. I'm going to have this all commented out rather. I want some things from here, so I'm going to copy this, and I'm going to yank it up here. Okay, and okay, so string, after declaring it here, next now to do is to begin a loop. I like to use the while loop. Yep. So while string is not null, why is not null? What I want you to do is first of all print. Okay, I would have copied this one from here. I read it already, don't worry. Let me go get it from here. So I'll kill this and yank it here. Where am I? Man, I miss Emacs. Seriously, I miss Emacs. Okay, let's do what I understand. Okay, so that's fine, and then I want to copy this as well, and I want to yank it here. So what is happening? I'll tell you shortly. And then I need to have a way. Okay, this is fine. This is okay. What is happening is I am using a loop to do all of these things that I did here. So it will be checking whether the value is now null. So long as that means and this null will appear when it gets the last one, which in this case is shell. When it gets there, it will now stop. It will now stop executing. The loop will now stop. I think let's try whether this works. Let's try whether it works. Let's see whether it's working. Okay. Save it. Compile. Look at that. So it's working. It's working. We're able to pass the command. How far? You need to create process rights and then talk about parent ID. Actually, I feel exhausted already, but let's just make progress. Okay, so let's go and incorporate it. Let's go and add it to our shell that we're writing. Okay, so I'm going to exit this file, and let's go back to our shell program. Let's see, nano shell.c. all right, so having used getline to get the input, we want to now tokenize the inputs. So add it. I think I should do that for later, so I'll be able to cover a lot today. Yeah, we'll be right now putting our simple shell together. Now you have an idea that we'll print the prompt, we'll get the input from the user, right, and then we will tokenize it, right? It's not our simple shell will not be printing doing this thing we are doing here, printing it to the user. you know, of course. And so we tokenize it. After tokenizing it, we can find out whether it is valid, and then if it's valid, we execute it. If it's not valid, we print error. All right, and we check: is it inbuilt? Is it executable? Things like that. I hope it's making sense. Let's talk about this before I go. Actually feel exhausted, honestly. Creating processes, producing child process. Okay, let's produce a child process with this. Okay, let's do something easier, something simpler, something quite simpler. So I'm going to close this, and I'm going to copy one of these files just so that will be fast. So let me copy string tokenize. Let's see, and I'm going to call this one. What are we dealing with? We're dealing with child processes. So let me call it child process dot c, and I'm going to open child process dot c, and I think we need what do we need? Yeah, we need some. I think the one that is worth copying is actually this other one. It has something we need. So let's copy the content of shell.c into child processes.c or child process.c. I think let's even change the name. Child process does not really. Let's call it create process. I leave that one. I like this one. Create process. Dot C. Okay, because we might need these libraries. Okay, so here we. What is happening? I'm using. I'll be using. Please, so I did not observe that I'll be using this prototype. There is no need. Is there? There's no need using the prototype. In this case, there was no need. So the void is enough. It's enough. Okay. Let's just have a program that prints. Let's just have a simple program. So I'm going to take all of this off. By the way, I want to move this up here. Because I need plenty of statements in this one, so I want to take all of this off. All right, of course I should have my return value. All right, let's create process, and let's be able to identify the process. And what is used to create a process is the system call known as fork. This guy here, right? How does it work? What does it do? How is it used? Let's go and find out. And we'll say create process, create child process. You're saying create another process that is happening. That means allow a process to produce a process. Make a process give birth to a process. So as in make out of a process a new process. That is it. This is where PID and PPID will make sense. That's why I left it and said I will talk about it now. By this time, I didn't want to talk about it then, so that it will move me to start talking about this function, this system call in that first section. And so let's go and find out from the manner how that guy works. Alright, so these are the two header files to include, and that's the reason when I copy this, they are here already, as you can see. I have sys slash types, and we have uni std.h. So I'll just uncomment it from here. Just remove the slash to become some codes. Okay, what else do we know about it? It creates a new process by duplicating the calling process. What do you mean by the calling process? The file that is running is the calling process. So it gets duplicated from when you call the function, it gets duplicated. Every other execution gets duplicated. So the new process is referred to as the child process. The calling process is referred to as the parent process. Alright, so the child process and the parent process run in separate memory space, right? Okay. Um, Now, at the time of fork, both both memory spaces have the same content. How do I explain that? Okay, I'll use my whiteboard this time. Memory writes, file mappings, what have you? Let's go. Uh, let's not complicate issues, right? But let's try to understand what I've explained so far. Um, we are saying that when, by the way, observe that this guy does not take any argument, but it returns this kind of data type, PIDT. What is the return value? Let's read about the return value. On success, the PID of the child process is returned to the parents, and 0 is returned in the child. On failure, -1 is returned in the parents, and nothing, no child process is created. Back to my whiteboard. I like to explain that like this. Let's say this is the parent process. Oh, let me make it look like stack. So I want to do this, and that gets this. So okay, so let's say this guy has some instructions in it here. Let's use blue to mark the first instruction. Let's use yellow to represent the second instruction. Let's use red to represent the third instruction. Let's use green to represent the fourth instruction, and let's use black to represent the duplication that happened. Let's say you now call this guy. Allow me to write now. You now call this guy here. Excuse me. Okay, if you don't want me to write, no problem. You now call this guy here. Once you call this function, make the system call here, it will now duplicate the process and create two identical processes. What do I mean by that? It will come here, causes duplication, and there will be two identical processes. But at this point, what will be identical is the point from where the duplication happened. So this child will have the same instructions. This same instruction in red now, it will not have it, and the other instruction in green, it will not have it as well, right? And so if everything works as expected, it will return its PID. On success, it will return to the parent process whatever its PID was. I don't know what is happening here now. Excuse me, sorry. Yeah, so it will return whatever the PID was. I forgive you. Embarrassing me before international community. Okay, it will return whatever the PID was, and but if it fails, it will return -1 to the parent, because it won't even have a PID here. It will return -1. If it doesn't fail, it will. So, but it returns zero inside itself because this guy has instruction to return zero, right? Inside itself, it returns zero. To the parent, it returns the PID. Okay. Now let's code. I hope I've explained that very well. Let's code. Okay, so I want to have a program here. Let's say it prints hello bears, how are you? And a new line. Alright, let's now make that system call here. As simple as that, no arguments. And then pass some more instructions here. Let's say printf I am executing all right. So we have in my sketch here I used 4 instructions example, right? But in my code now it's only 2 instructions, 1 2 1, then the call was made, second instruction. So this is the point where the duplication will happen. Let's see what will not be the case here. So I'm going to save this, go here, exit this place, and so I think I'll use it this time. It will be faster this time because this guy does not autocomplete. So let's call it okay, let's give it the same name. Alright, so it compiled with that error, and let's run it. I need to clear my screen, so pay attention to what happens. Alright, you want to clear the screen for me? I want to add a dot. Okay, so child process, let's go. Did you observe what happened? He printed the first one, hello pairs, how are you? Then something printed, I am executing. Another thing printed, I am executing. I did not even spell executing properly. So 2 processes ran, and something unusual is happening. The cursor is blinking at another spot, at an unusual spot. What happened here? What happened here? Anyway, let's find out what happened. The way we'll find out is to catch them. Is to make use of, let's take advantage of the return value. Okay, so go back to that manual just to show you. Okay, I think I've shown you now. I put this, I'll show you on the board as well. Return -1 if it fails, right? Remember, it returns 0 inside this guy if it worked. Okay, so we'll take advantage of those return values to place a check. So I'll come here and say, first of all, it's important that you place a check and say, let me declare a variable here of type PID underscore T. Is that correct? Let's find out. Man, st. By the way, this is still working. This is bash. Okay, so it's still working. What am I doing? Man. Okay, so it returns a data type, right? Okay, so let's call this R. I like to call it R val. We've declared R val, and we've done this. Come back. Okay, so we want to check now. Want to save the return value inside R val. So we use it to do our check. We'll now check whether it failed by saying if rval, because I want to catch the one that is executing last and the one that is executing first. Now, if rval is equal to -1, that means it failed. So what I want you to do is to inform us that it failed. Printf process creation failed. Let's do like this. Failed. And when it does that, it should return. I just wanted to give me a status. I choose to return this value, so that is unsuccessful. Else, because this is the point now, when if it didn't fail, it means it is at this point that they will start executing together, right? So I can as well not even link it to this statement, make it a different if statement and say if, right? This is the point where they start the program is duplicated. So we have two identical programs, with the same, they are so similar, the same instructions. So we'll check now if rvar is equal to 0. That means that's the child process running. If it's equal to 0, what I want you to do is print the child is executing. Otherwise, don't even need to add curly braces here. Okay, let me just add them. Else you mean that it is the parent that is executing, right? Else tell us that the parent is executing. Okay, so let's now go and check which one was that one that executed last and which one executed first. Having placed these checks. So again, only the parent has all of the instruction until something now happened here, and this one will only run if the function, if the system call fork failed, right? Man, this is so hard to pronounce it. Fork. All right. So if this failed, that's only when this thing will run. Otherwise, it should not even run. So the duplicating of the program began from here, and because it began from here, both of them has these instructions. But because there's an if statement, either of them can only execute one of them. Both of them can only execute either of these statements because the condition cannot be both true. Right, so let's go now and exit this place and compile again. What was that again? Yeah, it compiled. I want to clear again. Okay, I don't want to clear it now. So we want to know which one ran here and which one ran here. We are sure it was the parent that ran here because only the parent has this instruction. The fork system call had not been made at this time. Let's find out now by running it again. So, wow, interesting. And this is trouble. The parents had left the child and went and executed It's not for the child to, so the child now brought its return value to return and did not see the parents. That's why you're seeing this strange thing here. The child had to go to the grandparent. Who is the grandparent? The bash. Remember from last section I showed you that bash is running. So this guy is running on bash. This parent process is running on bash. But because he ran faster and finished, the child process came and didn't find it and went to uh, okay, it's actually more than that. It's actually more than that. And technically what happened here is that an orphan process, you know, has been created. So it didn't just run to bash, it ran to the number one process that happens. Okay, let me keep that for another time. Let me not confuse you. I think I'm giving you enough for today. But we can actually make the father, I'd say father now, the parent wait. The parent wait. So by giving instruction to sleep, add instruction and say, hey, sleep for, let's say, 3 seconds, because you know that this guy will execute in less than 1 second. So sleep. Let's save this and let's compile again. What's up? Oh, add the semicolon at the end of sleep. Okay, now let's compile again. So it compiled now. Let's clear. Okay, I won't clear it. Let me run it again. Did you see that? We have made the parent now to wait for the child. The child executed first, but there is still trouble. There's still trouble. We created a zombie process. Now, these terms are important too. That is you want to look out for when you're putting your shell together. Otherwise, you will write a shell that will put your operating system in trouble because you are interacting with the operating. This terminal helps us interact with the operating system, right? The shell that is running helps us interact with the operating system, and so we are making system calls. It's good as system calls. You don't handle it well, it could be dangerous. It could be dangerous. So when the child executes, you know, before the parents, that's distant. It will create a zombie process. While this one will go and create an orphan. When the parents leave the child, it creates an orphan. We'll talk more about what happened there, and then I think I want to leave. I'll leave this up to you. How to get parents PPID, the parent um, process identifier, and well, let me just do this before I leave. Let me do this before I leave. Let's say um, let me just use one of these programs that we wrote. So I'm going to exit here. Let me open any of this and just add let's use string tokenize. So nano string. Okay, so string tokenize. Let's now add those libraries that we need to use the getppid. I hope I will not make mistake. C/types h. I also include the std and h. Okay, so right now let's declare a variable here of type PID underscore T. Let's call it PPID. Let me just call it parent. And another variable. Okay, I think I can declare the variable in one line. Parents, child in one line, and here I want to print PPID and the PID. So print F the process ID is what would that be? Percentage I will work, right? Okay, let's try this. Percentage value, and I truly feel exhausted. Sorry. Sorry about that. So the process ID is the ID of the child. Oh, I think this is misleading right now. It's misleading. So let me just use PID and PPID instead. So this is PID. PPID. So it will be easier to understand. Because as I'm calling the child, I did not create a child process actually. So somebody might start thinking, did you create a child process? Why are you calling it a child? But every parent is a child, even your parents, they are the children of somebody. So every parent is a child of somebody, of someone, Okay, so the only process in the computer that does not have a parent is what we call the init. It has a PID of 1. That's one of the things I will talk about in the next section. Apart from that, every other process has a parent. So even when this guy is his own boss, is his own parent, there is no child there. But as a parent, he's running on something. Bash becomes its parent. We'll find out. So, but before doing this, I should have done this. Where I say PID equals, and I call the function getPID. Remember, I've done it before. I did this in section 1, and then I had to do something similar for the other one. So I will come here, paste it. I'm also going to yank this one. Now we'll come here and paste it, and so this one will be getppid. Getppid. This function. Well, this one is getppid. Okay, so here I will say the parent process ID is alright. Are we good to go? Okay, so it's doing its work. Let's say, let me change the string to checking the PID and PPID. Okay, now let's run this thing and see what happens. So I've just declared two variables of type PID underscore T. One I said is PID, one is PID. I assigned to PID the return value of getPID, and I assigned to there's a mistake here. PPID, the value of this, and I want to print from PPID. Alright, so we have two. I think that would have worked as well though. It would have worked. It was just reassigned. But I wanted to be two like this. Mm-hmm. So I need to have, I don't have my semicolon at the end of this, guys. Okay. Making progress. Now let's go and run this file. This is, what file is this? This is the um, this is strtok file, right? So let's compile. Plenty of errors. Get PID. What is it? Let's expected this before. Token. Where is it talking? What is it talking about? Who has seen the fault? This is what happens when one is exhausted. Okay, getPID ready. I'm leaving. Okay, I didn't. Rather than ask it to print a new line, I went down and escaped the end of the string. I think that's all. Okay, that's clear. Let's try to compile again. Some more issue. Long unsigned. Okay, let's humble ourselves and use integers. Alright, so everything's working well now. Alright, so let's run the file and see how it works now. Watch that. The process ID is 23251. The parent process ID is 21993. Let's run it again. The process ID is 23259. It has changed, but the parent ID did not change. But why? Let's cut a long story short. Remember that echo $$ shows you the PID of the current running process, and what is running currently now is bash, right? So that bash is the parent of this guy I was running. That's why it's not changing. So long as the bash is still running, it has not ended. Why? When this one has ended in seconds. So if it runs again, it's another instance. But this is the second instance of bash I've been using on this particular terminal. Of course, this other terminal will be running another instance of bash as it's different from the one that this one is running. So they will have different process ID. Let's confirm. Close this. Echo $. So see, this is 20913, whereas this one is 21993. I was going to use the PPID and PID in that function, but it might be a bit complex. I'll leave that to you. You go and do that. So we'll continue from here to the next section. Please show some support, man. It's not easy doing this. Show some support. Don't leave without liking the video, please. Like the video, share with others. Put those comments that I will see and be encouraged to do more. If you learn something, come on, your feedback is important, right? And if you're not subscribed to this channel, please do it to subscribe. I have more materials that will be helpful. You want to check them out.